Hello there, this is patch a day number 10, and we're going to make here something that's like recycle the old application that segments audio into beat segments or whatever. I'm going to start off with an SF play, and I want to load a sound file into this thing, so we'll make it message M for message. Open Jongly, one of our old favorites, AIF, which is a drum loop, and I suppose we'll need a toggle to start this thing, a 1 or a 0, 1 to start, 0 to stop. And just for a start, I suppose we could look at our our palette, and get an easy DAC. Why not? Turn it on, load up the sound file. Wow. Okay, so that's what we're going to deal with. We're going to want to use the amplitude as a kind of a measure for where to chop it up. So I'm going to use an average AVG tilde. And the thing that an AVG tilde always needs is a bang to output the average. So we'll use a metro running at 20 milliseconds, which is probably too fast really, but who cares? And we'll hook said metro into the AVG tilde. And as we've done before, we're going to put the AVG tilde through an A to dB, which will scale the linear, in computer language, linear amplitude into something that we can use. Let's just hook a float up to this A to dB right now to just check what kind of amplitudes we get out of it. Yeah, I disconnected that. I didn't really mean to, but it looks like it hovers around 20, negative 20. So I can put this back together, I suppose. So we'll check if we'll use a logic statement here to check if it's greater than 20 or negative 20. Hello, staying awake here. If it's greater than negative 20, we'll want to trigger something. So whenever you want to trigger something on a logic, you'll generally want to use a change to make sure it's not just continually sticking out ones every time while it's over 20, just when it changes. And we are going to eventually, let's just go a little further down here so that this might make some sense to you. We're going to basically store start and end points into this col object here, the sort of do-it-all storage object. Before we can get anything out of this sfplay object that will tell us where it is in the file, we're going to need to I'll look at the help for sfplay down here, which is below where I'm shooting this video, is the more features. And we can see under more features it says that if you give it more arguments, you can give it an SF list name, which I'm probably never going to deal with SF list, but if you'd like, we probably can figure it out. Channels, number of channels, we've already dealt with that. So 2 channels in this case. A disk buffer size, which if you don't use the default, you must know more about disk buffers than I do. And then number of position outlets. So yeah, you can give it 2 in this case, which will give you the current position and the current position round off. I could care less about the current position round off really. So we're just going to get the current position out of this thing. So some arguments here that would work according to that theory, according to my theories, is 1 for the number of channels, 0 to use the default disk buffer size, and 1 for the extra outputs. So if I can remember that, 1, 0, 1, EA. So there's the file position in milliseconds. We're going to want to use a snapshot to turn that into a good old-fashioned max value. All right, so there's the file position, and we're going to want to get that snapshot every time this thing changes. So I suppose we could just use well, let's use a select object. I know this will make some sense later on in a few seconds or minutes. We're going to want to get that value every time it's 1 or a 0. But to create a list, let's start making something that looks like we're trying to make a list. Pack 0, 0, 0. The list that we're going to store in the col is going to be the start position where it goes over this threshold, the end position where it goes below the threshold again, and then before that just a number which is a sort of index in the col. It's easy enough to create the index. We'll make an object to make the index. Let's make it store up to 100 values in there. So that's going to be that. We're basically going to need to route this thing to either the start position or end position, depending on whether it went high or low here. And I suppose the way I could do that really is to, well, one way is to make a gate with a gate of 2, and when this thing goes high, so I'm thinking about this, and now all of a sudden I'm thinking this needs to happen over here for the timing. When this thing goes high, well, let's just try this. +1. Actually, yeah, it wants to open the gate first, so I was right in thinking it needed to go over here. Yeah, it needs to open the gate or change the gate before it hits the snapshot, so that looks good that way around. So, I could be really pedantic about this and add 20 to the snapshot, and the reason for that is because because up here we can see that this metronome is running at 20 milliseconds. So our analysis is probably going to be about 20 milliseconds late. And it's either going to be, well, if this is a 1, which means this was a 0, then that means that it is now going low, which means that that's the end point. And if this is a 2, which means that this was a 1, it means that that's the start point. It means it was going high. All right. When I said +20, I guess I meant -20, but yeah. 20 milliseconds less or 20 milliseconds more? 20 milliseconds more, let's say, than measured. No, I was right. Sorry, I'm just going back and forwards. I'm like memory versus the future. So there we go. That should be fine. Oh yeah, we do need to trigger this. Oh yeah, that's the whole reason why I have the select 1, 0, because we only want to store this in the col when it goes low. So that's why we have that connected to select 0. Alright, that all looks pretty good to me. Next thing we're going to want to do is to, well, let's just make our life easier and just duplicate this. And we're going to use the seek message, which again, if we looked at the help for SF play, you'll see seek followed by a couple of numbers will be the start and end points for it to play back. So again, we want to hit that message to make sure it's open. And then I'm going to use prepend on the list coming out of col seek so that I can see where, so I can set where to start and end this thing. We'll probably want to hear that. Okay, a couple other things I might want here. First, I might want to see how many values are stored in the counter, so there's a nice integer box for us to look at that number. And then I might also want to, not new object, but another integer I. I'll probably want to be able to choose one of those fragments from the col on this end of things. All right, so if I hit the toggle up here, we should see, what should we see? I see an error message, no open file. I thought I hit you. Okay. You can see now that we've stored 12 segments in the col. We can double click the col to verify This one starts at -1, which is probably not a great place to start. Obviously my minus 20 on here was kind of off. And yes, that's all good. So it means that we can, these are the points, the peaks in the amplitude in that file, and we can read those back now. All right, now as with all of these sort of snippety little playback things, we might want to put something in here to stop those clicks. And again, it seems to be what we spend half of our time doing in Max. But let's just see if I can, well, we might need to give ourselves a bit more space. Let's just drag that up there. So yes, when we change this value, we'll probably want the amplitude. Let's just put this amplitude stuff in here. Times. That's for the SF play, and then we're going to use a line on that times on that multiplier. If you're dealing with percussive stuff, it makes some amount of sense to just go immediately to 1. So I'm making a new message with 1 when you trigger off the start of a sample, because clicks on the starts of percussive sounds are kind of cool. Yeah, all right. Yeah, when we want to find out the time over which this thing, we want to ramp it down at the end, so we need to know how long this thing plays for. So we can, this is starting to look a little message. We can unpack this list from the call and figure out the length of this thing by doing a reciprocal minus. So that would be the end minus the start. That's the end coming out here, minus this thing, which is the start. And so then we'll probably want to subtract the length of our ramp down, which will do a 20 millisecond ramp down. And we will then, yes, trigger, man, this thing is getting, all right, it's slowly disappearing at the top, but that's okay. Then we'll want to trigger a bang and an integer, which is the integer from here, into a del object, which is a delay. So we're triggering the delay with the delay time, and we're going to go 0. Well, we can just make a pack object here, 0 over 20 milliseconds for this line till here. That should have taken care of all the clicks, well, at the ends of the samples anyway. And if it isn't already kind of apparent, you'll change this value in here if you want to get more or less of those samples, or where the amplitude changes occur. All right, and so that was it for this little patch a day, and I'll check you in the next one. Bye.